Hello tech enthusiasts and curious minds from all around the globe. Before we delve into the fascinating process of how microchips are made, do us a favor and hit that subscribe button, give us a like and share this video around. It helps us produce more content just like this. In this digital age, microchips have become an integral part of our lives, present in everything from our smartphones to our coffee machines. Now brace yourselves as we take a journey into the intricate process of making microchips. Every microchip begins its life as a humble piece of silicon, but why silicon, you may ask? Well, let's delve into the heart of the matter. Silicon, the second most abundant element on Earth after oxygen, is the wonder ingredient that propels our digital age. It's the bedrock of modern technology, and there's a good reason for it. Silicon is a semiconductor, meaning it's neither a full conductor like copper nor an insulator like rubber. It's somewhere in between. This unique property allows us to control the flow of electricity through it, which is a basic requirement for any electronic device. But silicon isn't just any semiconductor, it's a very good one. It has a stable crystalline structure that can endure the high temperatures and corrosive chemicals used in chip manufacturing. But it's not just about being a semiconductor. Silicon is also a master of disguise. It can be doped or mixed with tiny amounts of other elements to change its conducting properties. This ability to switch between conducting and insulating states is what makes it possible to create the complex circuits that power our devices. However, the silicon used in microchips isn't just dug out of the ground and slapped onto a circuit board. It undergoes a meticulous purification process to reach an almost flawless state. It's heated to a molten state, then cooled very slowly to form large, single crystals. These are then sliced into thin wafers, polished to a mirror finish, and finally ready to be transformed into a microchip. So silicon is not only abundant and cheap, but its unique properties make it the perfect material for microchips. It's the unsung hero of the digital age, powering everything from your smartphone to your car to the internet itself. So now we have our silicon, but it's far from being a microchip just yet. Let's see what happens next. The next step in our microchip journey involves a technique called photolithography. Now don't let that hefty term scare you off. It's essentially the microchip equivalent of a glorious game of shadow puppets. Photolithography is all about using light and chemicals to etch intricate patterns onto our silicon wafer. If it helps, think of it as creating a minuscule silicon city, complete with circuits for roads and transistors for buildings. First, we coat our silicon wafer in a light-sensitive chemical fondly known as photoresist. This is akin to laying down the foundations for our silicon city. Then we bathe it in ultraviolet light. Now this isn't your average sunbathing session. We use a mask to block out certain areas, creating a pattern of light and shadow on the silicon wafer. This step is like turning on the city's streetlights, illuminating the roads we want to carve out. The illuminated areas of the photoresist harden under the light, while the shadowed areas remain soft and vulnerable. Next, we rinse the wafer in a chemical bath, which washes away the soft, unhardened photoresist, leaving behind the hardened pattern. Now we're really starting to see our city take shape. The buildings and roads are beginning to emerge from the silicon landscape. Finally, our silicon city is etched with ions, a process that's like adding all the finishing touches to our city. The parks, the trees, the quaint little cafes. The areas protected by the hardened photoresist remain untouched, while the exposed areas are etched away. And voila! We have a silicon city etched and ready. Photolithography, my friends, is a masterclass in precision and patience, a dance of light and shadow that breathes life into our silicon wafer. It's a process that's as much art as it is science. With our silicon city carefully etched, we're ready for the next stage. Remember though, this is just one part of the microchip's journey. There's more excitement to come, so stay tuned. Now comes the magic part. Ion implantation. Picture yourself as a master magician, and your wand is a high-energy ion implanter. What you're about to do is sprinkle a little magic dust onto our silicon city, granting it the ability to control the flow of electrons. Ion implantation is a fascinating process. It's about shooting ions, which are just atoms that are charged, into the silicon wafer. Now imagine these ions are like tiny seeds. As we shoot them into our silicon city, they get embedded into the silicon structures, altering the properties of the silicon in a controlled manner. You see, silicon on its own is a bit like a city with roads but no traffic rules. Electrons can move around, but there's no order, no control. It's a bit chaotic really, but here's where the magic happens. With ion implantation, we're effectively setting up traffic lights and roundabouts at strategic locations. The implanted ions control where the electrons can and cannot go. The process is a bit like baking a cake. You start with basic flour, but by adding different ingredients, a bit of sugar here, a sprinkle of baking powder there, you end up with a delicious cake. Our Silicon City is the same. We start with a plain old silicon wafer, but by carefully implanting different types of ions, we transform it into a semiconductor device capable of running our computers, our phones, our cars, and so much more. And voila! With a sprinkle of our ion magic dust, we have successfully altered the properties of the silicon. We've given it the power to control the flow of electrons, to follow the traffic rules we've set up. We have transformed our silicon wafer from a simple piece of material into an intricate piece of technology. Now our silicon is not just a city, but a bustling metropolis ready to handle the traffic of electrons. Our microchip city is almost ready, but it needs protection and connections to the outside world. So let's imagine, if you will, our microchip city is like a metropolis made of delicate glass. It's intricate, stunning, but oh so fragile. We can't just leave it exposed to the elements, now can we? That would be like leaving the crown jewels on a park bench. And we certainly can't have that. That's where packaging comes into play. It's like building a fortress, a protective dome around our Silicon City. But this isn't just any old fortress. It's a fortress made of plastic, ceramic, or metal materials that can withstand the harsh realities of the outside world. They're like the knights in shining armor, safeguarding our precious microchip city from dust, moisture, and other potential threats. Now, a city isn't much good if it's all sealed up with no way in or out. It needs connections, highways, if you will, to the outside world. In microchip terms, these are the pins or leads that stick out from the package. These are the bridges, the tunnels, the ferry services that link our microchip city to the rest of the digital world. They're crafted from gold or copper, materials known for their fantastic ability to conduct electricity. In essence, they're the microchip's lifelines, allowing it to communicate with other devices, send and receive data, and ultimately do its job. So we've got our city, our protective dome, and our highways, but it's not quite as simple as slapping it all together. The process requires precision, accuracy, and a fair bit of finesse. It's like playing the world's tiniest game of Jenga, only with a lot more at stake. But once it's done, once each pin is perfectly placed, each protective layer precisely positioned, we're left with something truly remarkable. A microchip, ready to power everything from your smartphone to the space station. And there we have it, our microchip city is ready to power the digital world. Isn't it amazing how a simple piece of silicon can become a powerful microchip? We've walked through the intricate journey that transforms this humble material into a computing powerhouse. We've started off with the birthplace silicon, a common element with extraordinary potential. Through careful purification and cultivation, we've seen it morph into a perfect slice of ingenuity. We've then delved into the sublime art of photolithography, where the silicon wafer is etched with a labyrinth of complex circuits. This process, akin to a microscopic tattoo, is where the silicon really begins to take on its new identity as a microchip. Then came the magic ion implantation. By bombarding the etched silicon with ions, we've manipulated its properties, turning it into a semiconductor and giving it the ability to control electrical current. This is the heart of what makes a microchip tick. Finally, we've encased our silicon masterpiece in a protective package, which not only shields it from the harsh realities of the outside world, but also allows it to communicate with other components. Throughout this journey, we've seen the astonishing precision and complexity involved in creating a microchip. It's a testament to human ingenuity and our relentless pursuit of innovation. We hope you enjoyed this journey into the world of microchips. Don't forget to subscribe, like, and share if you did. Stay curious, and we'll see you in the next video.